Hello everyone, and in this video today, I will dig deeper into two concepts. First, normals, and second, how noise works in any 3D software. So I will share what is a normal, what normal do, and how Houdini calculates the value of a normal, and if you are adding normal to a point in a 3D space with its position vector x, y, and z, and how Houdini will add these two and give an output. And I will share how the noise works and how Houdini calculates noise and how it can affect our geometry. And these two are really understand, and I will share like how this works and why they does the things they do. So I have this scene. I have nothing over here. First, I will, as always, I have created a geometry container. I have this X form float over. I was working on this before, so I have this geometry container, and I will give here a box, and I will show you what are normals. So you see here each point is showing, like I have toggled on this and this. This is our normal and this is our point. So if you toggle this on, you will see points, and if you toggle this on, you would see normals of each point. And you are seeing three lines coming out from this point, and this is our normal. This face has this vertex, this face has this vertex, and this face has this vertex. So this point is sharing three vertices. So right now we are seeing this, and we have the normals, and they are perpendicular to the mesh. To the mesh, these points are connected to. If I say an add and I add a point, and when I toggle this on, you see we have a point now, right? And I have toggled this on, but we are not seeing any normal coming out from this point, because normal gives us the direction of the point it is facing. This point is, we don't have a direction of this point facing, because we need a surface. We need a surface to see our normals. Normals act like a direction the surface is facing. That means if I toggle this box on, we have this point facing, this vertex is facing this direction, this vertex is facing this direction. If I create a grid, not group delete, sorry. If I create a grid, you see I have had an issue with my camera. So now first we have this vertex is facing the y direction, and that means this mesh is facing the y direction, and its front is this and back is this. Whichever the direction normals are facing, that means it's our front, and the behind it, the other direction is our back. So what is a normal? Normal is a unit vector with a direction. Normal tells us what is the direction of a point of a mesh, right? It's only tells us the direction, and it has a magnitude, a value, or magnitude 1. Unit vector is a vector that has a direction and a value 1, right? These are unit vectors. So for example, you have a point P and its position, and you have, let's say you have a point P and its position is x, y, and z, right? This is a vector. We have its components, right? Its values here, x, y, and z, and it has a direction. When you are saying this point exists at this value in this 3D space, that means it has a x value, something in y, and like somewhat in z. That means, let's say you have something like 0.2, 0.3, and 0.4. Okay, this is the position of this point, and that means like somewhat 20% in x, right? 30% in y, and 40% in z. This is giving us a ratio of where this point exists in this 3D space. This is a vector with a direction. So when you know what a normal is a direction. Normal is just a way so we can know what is the direction of that primitive or of that point. So we know what a normal is, right? So what if I give this an attribute VOP and I toggle this on? We have this cube, and when I go inside this, we have this. What if let's create a sphere. We have this sphere, right? And we have, let's toggle off the normal display and primitive normal display, and let's say polygons and frequency, let's say 100, right? Toggle this off, and we have a very intricate sphere right here, and we have like thousands of points here. So what if I connect this to this, and let's make some changes over here. So let's say first we know now what are normals, right? So what if I want to displace these points, right? These points in this 3D space. And what do I mean by this? When you go to this, and when you transform this sphere, when you transform this sphere, what you are doing here, when you scaling this sphere, you see these points are moving in 3D space, and they are creating this silhouette that looked scaled, right? How we scale a geometry. If you want to scale a square, that means you are taking these points and you are like putting it somewhere in the 3D space. So the box, so the cube is now looked scaled, right? So I want to do the same, but like from inside this VOP level, what I can do, I want to like move these points in 3D space so we can have a scaled look, right? So what can I do? What if I connect this position and normal together, and we have this add node? What is this add node? We have add SOP, like we had add SOP, right, at the geometry level. That SOP were used to create geometry, right? Points, polygons, and this add node is just mathematical addition, just value addition. Here we use mathematics, and there we were creating geometry from that add. And I have prepared some notes, and I will like show you at the last of this video. So let's add this position P, right? Now we are reading the position components, position vector components, and we have here, when you go to geometry spreadsheet, you can see now each point position in this 3D space. We have its x, y, and z component value, right? So now we are reading the position vector components, right? Position value from this position parameter, and now we are like outputting it in the position. That means we are reading this and we want to make some changes, and we are saying it in the position. That means the change we will do will transfer it in the position value, and when we make changes in the position component vector components value, then we would see that the points has been shifted. So let's do something here. Let's say constant. I told you in the last video, just a number, and we have now float, right? Float is value with decimal, right? It can be anything, 5.23, 9.84, right? So now when I like increase this float value, we see it is translating in this 3D space. That means we have this, right? Let's say this point 0 has this position, right, in this 3D space, right? So when I give this one, when I'm adding this one value into this point position components in the 3D space, components are like vectors with value, right? So when I'm adding this one into this its position, you see now the one has been added to its position. That means the points has been shifted to one unit. The points has been shifted to one unit in this 3D space. I'm sorry for this, again having issue with my camera. Let me restart my camera real quick and I will come back. Okay, so what we had, so now when we were adding this value into the input 2 into the position P, so this value is now has been adding to this position value we had before. What if I delete this value and I connect this into the input 2? Now it has scaled. It is scaled, and why? I will explain why. So this normal parameter is giving us a value. We are reading this position components, position vector components, and it has its value, right? Each axis has its value, position value. So and we are reading this normal, so I will create a notepad here. What this normal is giving us, this normal is giving us a direction, right? A direction, and we know that its length is 1 unit, because normal is a unit vector. It just gives us a direction. So let's say, and I will I will tell you here. So let's say you have a normal with a direction, and how would you tell a normal its direction? Like you are saying that my normal points this way, but how would you tell a software, a 3D software, that which direction? You cannot just show it that the direction is this way. You need something, you need a value, right? So we tell a 3D software the direction in like components value vectors. So the normal is now has x, y, and z. And you would say this is just a value, this is not a direction. This is a direction with a value. Let me explain. You have three axes, x, y, and z, right? So when you say, let's give this, let's take this example. You say 1 0 0. You know that this vector is facing the x direction, and the tail of this arrow would start from the center, right? From the center of these axes to the point where it is located. That means the x value is now 1, which this shows us that it has a direction, x direction, but with a value, and the value is like we have to calculate the value. If I say I have 2, 3, and 4, then how would you calculate its length? If you are saying that this point is located at this position, then how would you calculate what is the length of this vector, what its magnitude, what's its value? So how Houdini calculates its magnitude or value, we have square root. So we can just say square root or square root of x. How I put square, x square. Okay, I will just explain this. Okay, how we calculate the length? We have square root of x square plus y square plus z square. We have this formula to calculate the length of a vector: x square plus y square plus z square, and square root of everything together. So we can have, and I would just put the formula somewhere in the screen, on the screen, and if the length is more than 1 unit, you are saying I have a normal which has a direction in values x, y, and z. If the length of the x, y, and z is more than 1 unit, then how would you say that it is a unit vector? Because a normal has always a length and a value or a magnitude 1 unit, unless you give it more, right? So how would Houdini calculate? Like, you are saying my normal is facing this direction, right? If the point is more than, like, if the length of this vector is more than 1 unit, then how would Houdini give it a 1 unit length? So I have Houdini calculates every time. It normalize. We say it normalize the vector. And what normalization means? If a vector has a value more than 1 unit, it is not a unit vector. So how do we convert a unit vector? How do we convert a vector which is not a unit vector into a unit vector? Just take any vector. Right? Give its magnitude a unit, a value 1 unit, but keep its direction. Now the vector would be a unit vector. Let's say I have a normal. with 2, 3, and 4, in 3D space, this is the normal direction plus its length, but we don't know the length yet. So first, what Houdini will do, it will calculate its length. And how it will calculate? X square plus y square plus z square, whole root of everything like together, and then it would normalize it. And how it would normalize it? Let's say you have a vector 1 2 1 2 3, right, and its length is, let's say, 5 unit. This is not correct. I'm just giving an example. The length is not 5 unit. I need to calculate it, but for example, I'm just taking it as an example. So its length is 5 unit. How would you normalize it? How Houdini would normalize it? It would say x divided by 5, y divided by 5, and z divided by 5. Now we have a normalized value. Whatever value will come after this, it would be our normalized value, and that value, let's say you have 0.1, 0.1 or 0.3, this would equal to 1 unit. This would equals to 1 unit, and this 1 unit is equals to this, and this is also the direction this vector is facing, because we took its direction. We just changed its magnitude to 1 unit. This value would be 1 unit, and this value was not 1 unit because its length was more than 1 unit. So we kept its direction, but we changed its length to 1 unit. We just calculated how, like, where 1 unit points would be in that same direction. So I guess you understand this. I would paste some screenshot here so you can understand this better. I will write the formulas and everything so you can understand it better. So now this is too big. I will just put it here. So now you have the normal value, and it would be a unit vector because Houdini already calculated its length, and it already normalized it to 1 unit, right? So we have this value coming out from this normal parameter input, and it is going into the input too. So now we have position, and now we have normal values, and now we are adding it here, and the sum of these two are outputting to its position P. When I disconnect this, you see it's getting smaller, and when I connect this again, it's getting bigger. Now we are translating its point to this direction, to whatever the direction this normal is giving us, right? This normal is giving us a direction and its length, which is 1 unit. So these points are now translating in the direction of this by 1 unit, right? You understand this? I hope you did. If you have any query, if you are watching this, then if you have any query, then you can put in the comments and I will try to make you understand it. So I hope you understand how Houdini calculate the values of the normals and how it is we are adding this, what value this node this point is giving us, and we have this position. I will say it again. I will tell you again. This point P position is giving us a value components, right? And we are adding this normal value into this, and now we are translating these points in this 3D space. And we can like add something here also. We are just adding here. I just wanted to explain how normals work because it is really important. So now you know, if we add position and normal and we give this input, so now we are translating these points in the 3D space. What if I give this noise? We have different types of noise. We can use any noise, let's say periodic noise, and we have the position, and let's say we have many types of signature here. For this example, let's say noise, let's use anti-aliased noise, right? Anti-aliased noise. And I want to share something here, and I want to tell how noise works. So if I am disconnecting this, let's say I am connecting this parameter position p in the position, this parameter p, which is giving us components in x, y, and z axes, and I'm like outputting this into p. We see nothing. We see nothing because we have two different types here. We have 1D, we have 3D. And I will show you first how noise work. Noise works. For example, I would tell you how noise work. Noise is just a random value given to a parameter, attribute, anything like position, attribute. Noise is just a random value. For example, we have different parameters here. We have 3D frequency, amplitude, roughness, max, octaves, and I will explain each of these first. Let's say what these points says. We have point 0, its components, vector components is 0, 0, and minus 0.5. I'm saying the amplitude is 0. And when let's input this value in the noise value here, and let's increase the amplitude. You see it is doing something, right? And I'm going to explain this why, and why when it's connected here it is giving us an output, right? First, I have directly connected this to its P. Now the position values that are coming from this point into this AA noise is giving us an amplitude 0. So what noise gives? For example, you have a value, let's say you have a point and its value is 2, 3, and 4. Okay, you have a point and its position value is this. Okay, now you are connecting this to noise. What you would get, let's say this noise has amplitude 1. That means this noise, the value that is coming out of this point, which is 2, 3, 4, and noise amplitude 1. Noise will give a random value to each component, to each axis value, a random value, and it can add or replace that value. Do you understand what I mean? So it will give you a value from, if we have 1, that means it would give this a value from -1 to 1, right? If we have amplitude 1, it would give -1 to 1. If we have 5, it would give -5 to 5, any random value. And by this example, I will show you how. Let's say you have amplitude and it is like, now we have two noises, 1D and 3D. I will explain it later, but for now, let's say it is giving up a value. This noise is giving us a value, let's say 0.5. This noise is giving us a value 0.5. So how it would act? This noise can replace this value or add this 0.5 value to these, so we can have a now updated value. So what updated value will we have? We will have P, right? P and 2, 2.5, 3, 3.5 and 4.5. We would have this updated value. This noise gives a random value and it depends on its amplitude, magnitude and max octaves. I will explain it, but you see here how noise works. So this noise, it has an amplitude 1 and it is giving us a value 0.5, so it can replace or add. Right now when we have connected this directly to the position vector, it is replacing the values coming out from this, and it is now giving it a random value and outputting this in the position parameter. And you would see here we have nothing because we have a 1D noise. 1D noise, we have two types of noise, 1D, or we can have 3D, we can have 4D, but let's say 1D. 1D means it is giving us a value, one value. That value is going into each component, into each axis value. What do I mean by that? If we have position 2, 3 and 4, right? It is giving us one value and it is now replacing this P with 1 with let's say 0.5 and 0.5. This amplitude is giving us 0.5, and if we have 1D, then this 0.5 value is going into each component of this position vector P. We have 0 because we have amplitude 0. Amplitude 0 means it is giving us a value from 0 to 0. That means the value would be 0. It is now replacing the values, replacing the position vector values coming out from this point, going into this, and it is giving it a random value and outputting it into the position. That means we have this. And when we have 3 dimension, it is giving 3 values for each component. It is giving us 3 values for each component, for each vector component. For example, let's say it is giving a value for x 0.1, 0.3, 0.1 for y, and 0.4 for z. Let's say y, it is giving 0.4, and for z it is giving 0.5. This is just a representation because I'm just representing this x. That means x is 0.3, y is 0.4, z is 0.5, right? Okay, so now we would have what we would have after the noise value. We would have let's say we had, this is our original position, right? And after the 3D noise, it is giving us 3 values for each vector component. So we would have 2.3. Wait. Okay. So after this, we would have it would replace it, because we are not adding it. We are like, we have directly connected it this to this. So the values coming out from this is now like it's now replaced by these noise, and now it is outputting the value into the position back to the world. So now the position values would be 0.3, 0.4 and 0.5, right? For each point, let's say I am giving this let's say 1. Let's give this 1. So when you open the geometry spreadsheet, you would see we would have same values for each point, because this noise is now replacing and giving it a random value in like 3 components. It is giving 3 values for each vector component, that is x, y and z. So now we have something like this. But if we say 3D noise, we would have something like this, because it is giving each point a random value. So points don't know what was the original geometry, and they are just randomly placed in this 3D world. And now we have something like this. It is messy. Okay. What if we want to add this noise over that like position we had? So when I disconnect this, when I give this here, we had this sphere, right? We have points of this sphere, and when I read the values from this, and when I'm adding this noise to this, now it is giving each point vector component a value, but this time it is adding the value over the value we had. So when I disconnect this, we had something like this. Each point has a value, right? And when I connect this into the position of this noise, now it is giving it a random value, but the value is now added to the value we had, the original value we had. Now this value is now just added to the original value we had. And when I decrease the amplitude, you see the noise is now working fine. Now the noise is giving each point a value, and now each point is displaced in the 3D in this 3D world, and now we have something like this. You know how noise works, right? This is really important, because we know that noise is something that displays or changes something, right? It gives a random something, but we don't know how it works. But we now know how it works, right? So we have something like this. When I increase the amplitude, that means the value would be from minus 0.062 plus to plus 0.062. That means the value is little bit, it's not that far away from each other. So we don't have that much deformation in this sphere. When I increase this value, now the values are like far away. So we have different values, and Houdini is now adding these values to the original position values. So we have something like this. What if I increase the roughness, and how the value is changing by this roughness? If I'm saying I have the noise values from minus 1 to 1, that means we can have 0.2, 0.25, 0.23 or 0.25, right? When we increase the roughness, the values are now going extreme to these points. Now we have something in between, like we have a space in the values, right? So now the values are like, these values are like similar, but we increase the roughness. Now the value would be 0.2, then 0.6 or 0.7. Now these values are like far, like they have a difference in between them. You can see physically that 0.2 is displacing a point here, and 0.7 is displacing another point right there. So we have this like huge spike. That's why when we increase the roughness, we have these huge spikes. I now think that you understand what I'm saying, right? Okay. And now we know how noise works. What if I cut this and give this noise to the CD? Now we are seeing some colors. But what is this doing here? I will tell you one thing. You are reading the values from this position for each point, right? You are giving this, now it is directly connected to this, so now it is replacing these points values from the value -1 to 1 and giving back to the CD. Now we have a new attribute which is CD, and the value is where the values are coming from, this point, and now it is replacing these value by this noise. So these values are directly affected by this AI noise. Now when you increase and decrease the roughness, like amplitude, you are seeing that we are like seeing some changes. What if I say that 0? It would be 0 because this is where the values are coming from right now, because it is connected to the position. It is reading the values from the position parameter here, and now it is replacing these values by random values from 0 to 0, which is nothing. So if I say 1, so it is now giving each CD RGB its values from -1 to 1. And in the last video I have told about, if a vector RGB is a vector as same like and when you connect the value, when you connect the vector from P, which is position X, Y and Z, directly to that CD, now the R is like reading the value of X, and G is reading the value of Y, and Z is reading the value of P. So what would have now, we have some values in R, G and P. RGB values means color, right? If we have something red and something like yellow and something red, green and something like blue, that means we are seeing some colors. And now this noise is giving some random numbers, and these numbers are now creating some colors on our geometry. If you increase or decrease the amplitude, now you are seeing some colors. When you say we have 0, why is this black? Because these 000 RGB value is like gives color black. Okay, I hope you understand this, how this noise value is affecting this geometry and how this all works, because this is really important. We don't like, if you are doing something, then I think that we need to understand the basics, how things work. I haven't like seen anybody talked about these, like how these value works. That's why I'm sharing these, because these are also important if you want to really know these concepts. I have created some examples for you, and I have some notes. You can just pause the video here and you can read these notes. I have talked about add SOP and add VOP, how they are different. We have this add VOP here, and when we go to geometry level, we have this add SOP, and you have seen here it is creating a point in this 3D space. It is creating a point, but this add value, this add VOP node, which is vex operator node, it was surface operator. Surface operator were creating and modifying the geometry. This is creating or modify the vex code. So this is our vex operator, and this add is just this add input 1, input 2, no geometry, no points, no polygons, just pure math. And add SOP were used to created new points, create new polygons, create curves, create points to lines, delete geometry, but keeps point. Like it modifies or creates the geometry, but VOP only adds. It's mathematical addition. That's it. Okay. Yes, I forget to tell you about the noise octaves. So I will show you what this octave is doing. When we are wait, where were we? We are here, right? Yes. So we have the sphere. What if I disconnect this so you can see it clearly? and give this something like this. Now, what is max octaves? If you have, let's say you have 0. Okay, let's say you have 0 octaves. 0 octaves means layer of that noise. Layer of that noise. You have max octave 0 here. That means it is changing the position of the parameters and giving, like, changing the position of the points and giving them like random values. But if you want to add values over values over values, that then you have octaves. Now we have one layer of this random noise values on these. When you increase the octaves, now we have another layer of the value adding to this, another layer of values adding to this. And when we have more octaves, you see we have now changing, it's increasing the value. You see it is increasing the value, it is giving it a random value, but we are now giving it a noise value, then adding another noise value, then adding another noise value, and we have something like much more detailed. We have soft, then we have much more detailed noise here. This is what octaves do. It's just number of layers, and in the next or any other video I can explain how it calculates the values, but we don't need to know it right now, so I can skip it here. But you know now what octaves do. It is just noise over noise over noise, and you can have many layers and you can have much more detail, right? Same, it's just values. CD is just values, it is just values, details, values, right? So let's go back to our notes, where here, I guess, yes. Okay, and we have something like this. You create the value inside VOP, output node says Houdini where to write. Okay, it was simple. Normal, what is normal? I explained it. Normal is a unit vector with a direction and magnitude 1, example 300, and unit length 1. Position is not a unit vector, it's just a location, right? You had a position of the point side, now have normals each other, value plus direction, some normal value. You can like screenshot here, and I have already explained all these. Okay, so I think this is it for this video, and if you have any doubt, any query, you can ask. Normal is something like this, you can screenshot it here, and if you have any question, if you want to understand anything, you can just put this and like ask some like AI agent, ChatGPT you can use. And what I would share here, don't like just skip concepts. If you are having some difficulties to understand some concepts like how normal works, you don't need to understand them, you don't need to understand how noise works, but this is just a plus point for everyone who understand these, and I know how crucial they are, so I will just say that please try to understand the concepts behind things we do in any like 3D software. I hope you understand something, you understood something from this video, and I will see you in the next video. Bye bye.